We're going to jump from population standard deviation into sample standard deviation. And the formulas are essentially the same. The only difference is instead of dividing by n, we divide by n minus 1. Now that statement's going to change in data types later on in the semester, but right now we're looking at n minus 1. And the computational formula is also similar to the other one, except the final calculation is n minus 1. I'm going to send a short video link that explains more about what degrees of freedom are. The short version is take your sample size, subtract 1 off of that, and that gives you, anyways, you're just n minus 1. All right, so we're going to calculate the sample standard deviation given a random sample of 5, 26, and 36. And let me get a spreadsheet going here. Okay, so we're going to fill out pretty much the same spreadsheet as before, only this time we have a lot smaller numbers. So let me go back in and let me clean out all of these lists. Remember, if you're going to do my approach, hit clear and arrow down. Very nervous about that, it seems. All right, so 5, 26, and 36. And this would be good practice to see if you remember how to set this up. So if you want to pause this and see if you can work ahead of me, it's not going to change until the very last step where instead of dividing by 3, we divide by 2. But other than that, it's going to be the same. So then we want the mean. So I'm going to go tell the calculator to give it to me. Over to mean of L1. Okay, and then I'm going to have the calculator remember this. So I'm going to store that number, and I'm going to store it under A. Okay. All right, so let me go back over here. Oops. Over to edit. Now I want, I'm going to highlight list 2. I want L1 minus A. My fancy formula. Okay, and that gives us that set of numbers there. So now I've got x minus mu. So now I want to square that. So I'm going to go over to list 3 and square it. So highlight that and then just pick list 2 that we square. Okay, and then let me go back up top to the formula. So the formula says sum that the squared, so sum list 3 and then divide by n minus 2. Alright, so go back to here, and then we want sum, which is under math. And this time I want to sum up list 3. And then I'm going to divide that by 2. And then I want to take that number and I want to square root it. And that gives me a standard deviation of 15.82. Okay. So that would be the sample standard deviation formula. Let me do the same process with the computational. I kind of like it, and that there's less buttons to, I would say less buttons to press, but it's less hanging out on the list screen. So if I go back over to stat edit, let's see, I am just missing where I square list 1. That's it. So I'm going to put that under list 4 for me. So go up top and then just tell the calculator to take list 1 and square it. And I get those numbers. Okay. So I go back here, and this says sum that squared list. So I want to sum list 2. I'm sorry, sum list 4. Let's try that again. Then I want list 1. I want to sum list 1, and I want to square it. So let me get the sum here. And I want to take that number and square it. And then I want to divide that by n. So I actually do want to divide that by 3. And so that number, that's this fraction here. So I want the original list 1 squared, the sum of that. So that would be up here, the 1997. So I want the 1997 minus this other number. And then I want to take that and divide that by 2. And it's the same number it was before. So take the square root. And I get 15.8 again. So there you go. That's how you calculate standard deviation by hand. I know it sounds weird. We use so many calculator skills for that. Okay, so earlier we looked at the Wendy's data and the McDonald's data, and we looked at histograms of it. We're going to look at the standard deviation of this, so I'm going to show you a calculator skill related to that. So if you'll go, we're not going to do it the long way anymore. I'm going to show you physically how to calculate it, or how to get the calculator to spit out and tell you the standard deviation. So if you want to clear your lists, and then if you will go in and type in each data set, and just so we're on the same page here, we'll put the Wendy's data in list 1. So you can type all that in, and then we'll put McDonald's into list 2, and then we'll talk in a second about what you do with that to get the standard deviation to show up. Alright, so now that you have both sets of data typed in, again, Wendy's in list 1, McDonald's in list 2, there's 2 ways that you can go about doing this. I'm going to show you an individual way. So if you just want just the standard deviation, if you go to the home screen and then hit second list again, go over to math. This is the same place where we were getting the mean and the median earlier. So you can scroll down to standard deviation and then just tell the calculator, I want the standard deviation of list 1. And then you can do the same thing. I want the standard deviation of list 2. Now, yes, I understand that's a lot faster, but you still need to know how they calculate these things. They're not just magic numbers. So that's one option. There's one more option that will actually give you the mean, the median, and the standard deviation all wrapped up into one. So if you go to Stat and go over to Calc, if we do one variable statistics, and then just tell the calculator where the data is stored. Now, frequency list just means if one of our lists talked about how often something showed up. So if we're looking at relative frequency, that would be that. Anyways, so if I hit one of our stats and hit enter, it will calculate the mean. Sorry, it gives us the X bar. So the calculator thinks it's a sample, and that's fine. So it gives us sample mean, gives us the standard deviation of the sample and standard deviation of the population, and then a whole bunch of other information which we will eventually get to learning what all this means. And then we can go back in and do the same thing for the Wendy's data. I'm sorry, McDonald's data. I got ahead of myself. And just switch, instead of L1, just switch that to L2. And then hit enter. And it does the same calculation. Gives us the mean, standard deviation, population, and variance. I'm sorry, population and sample. Okay. Okay, speaking of which, variance is if we don't take the square root we get variance. There you go. So if we have standard deviation, we just go back and square standard deviation to get the variance. All right, and the last sort of topic to address in this video is what's called the empirical rule. I prefer its numerical title, which is the 68, 95, 99.7 rule. And this gives us a reason why we care about standard deviation. This tells us that if our data happens to be roughly bell-shaped or symmetrical, that I would expect, and this is what symmetrical means, I would expect 68% of the data to be within 1 standard deviation of the mean, 95% to be within 2, and 99.7% to be within 3. This gives us a way to actually measure whether or not a particular data set is bell-shaped or symmetrical or not. But moreover, it also lets us talk about how often or talk about the probabilities of certain events occurring. So this is a start of a wonderful relationship that we will come back and use for lots and lots of things. Graphically, what I'm trying to get you to understand here is if we have a mean and I go out 1 standard deviation in each direction, I would expect 68% of the data to be within that range. If I go out 2 more standard deviations, now 95% of the data is within that range, and then 3 standard deviations would be 99.7. Okay.